Okay, hello everyone, welcome. My name is Marcin Wielgus. I am the leader of the Autoscaling special interest group in Kubernetes, and I would like to join the keynote speakers and welcome you at KubeCon and in the beautiful city of Barcelona. Barcelona is a very popular tourist destination. Many people visit it because it's the gateway to beautiful beaches of Costa Brava and Costa Dorada. Some people come here to visit famous monuments like Sagrada Familia, Park Güell, Gothic district. Others enjoy the city atmosphere and love to walk through vivid and bustling boulevards like Rambla. There, among acrobats, painters, cartoonists, beggars, and pickpocketers, if they look carefully, they can spot them. Fortune tellers. The fortune tellers for a handful of euros will tell you your future. Will tell you your good and bad moments to come, who will be your prince and princess charming, whether your current love will last for the lifetime, and if they are really, really good, they will tell you what will be the names of your grandchildren. They will answer any of your questions. Well, almost any. Imagine that you are just about to launch a new service and you are nervous, anxious, and you want to validate your assumptions, and you come to a legitimate-looking fortune teller and ask this: how much resources do I need in my cluster? How many pods should I have in my deployment? How big my pods should be? Well, they will react with complete astonishment. The sad truth is that currently, there are no cloud-native certified fortune tellers who understand the internals of Kubernetes, not even in Barcelona, not on La Rambla. You can ask these questions to your developers, DevOps, admins, product managers. They may have a really good grasp on Kubernetes and your product domain. They can do a lot of measurements, tests, checks. However, most of the technical people don't have strong clairvoyant skills. And life will always find a way to surprise you. Proper pod count for today, maybe too little for tomorrow, when the traffic increases. An absent-minded developer may forget to mention that he increased the cache in your application 10 times and now it starts throwing out of memory exception. Someone from another team may start another workload in your cluster, depleting its capacity. And you will be called to fix it, if lucky, within your business hours. If slightly less lucky, at 3 a.m. on Saturday. And obviously, you don't want to be woken up and called with alerts. You would like to have an automation, a robot who would observe your cluster and add or remove computational capacity when needed, to keep your workloads healthy and, what is equally important, to keep your monthly bills as low as possible. Luckily for you, we have a couple of such robots in Kubernetes, and now I'm going to describe them to you. The first robot is called Horizontal Pod Autoscaler. Horizontal Pod Autoscaler is based on metrics that express the load that your application gets. It can be either real CPU usage or something a little bit more custom, like the number of queries per second that are coming to your application, or other gauge-like value provided by the user. HPA takes the value of these metrics, compares it with user-defined target, and, depending on the result of this comparison, adds or removes replicas to move the metrics toward the desired value. Let's take a look on how does it work in practice. But before that, let me clarify something. While talking about Horizontal Pod Autoscaler, I will use a word utilization. I understand it as a ratio between the current load, expressed by some metrics, and the maximum amount of load that your application can handle. For example, if your pod requests 1 CPU and is currently using half of it, then your utilization is 50%. If a pod can handle 1,000 QPSs, but is processing 200 at this moment, then the utilization is 20%. Okay, now the mentioned example. On this example, we have 4 pods that are burning hot and are reporting very high utilization. their load is above the target. They use almost all of their capacity. Should the traffic increase, there might be not enough computing power to handle it. But if we add another pod and the same traffic is spread across 5 pods, then the average per pod load obviously will decrease, leaving more space for spikes and coming closer to the desired target. In this way too, if the situation is slightly different and all of the pods are below the target, like significantly below the target, then it might be actually beneficial to delete one of the pods. And then the traffic on the remaining pods will increase, the pods will be better utilized, and you will have more resources in your cluster. And this is what horizontal pod autoscaler does. It adds and deletes replicas when needed. When to use HPA? Horizontal pod autoscaler works best with stateless serving workloads that can spin up new replicas reasonably fast. You can also use horizontal pod autoscaler with queue-based processing. How to enable it? HPA is a part of core Kubernetes APIs. It is controlled by HPA object. You can create this object either with YAML file or by kubectl autoscale command. CPU usage is available out of the box. Custom metrics require a little bit more work. While setting up horizontal pod autoscaler, it is crucial to set the target value, or more generally, target utilization right. The simple formula, 1 minus utilization, is the size of your spike buffer capacity and the driver for scale-ups. Too small spike buffer may prevent scale-ups and may overload the application. Too big, obviously, waste your money. The value of the target utilization should allow your application to run with the increased traffic, but with the old number of replicas for at least 2 minutes, to allow HPA reaction, possibly node provisioning, and starting new pods. So, if you expect that within any 2 minutes, your traffic may rise by, let's say, 50%, your target utilization should be set to 65% or less. If it can double, to 50% or less, and so on and so on. What are the other best practices for horizontal pod autoscaler? Application under HPA should correctly handle SIG terms. This means that after receiving the signal, the application should not stop but finish all of the requests that are currently in flight and still listen for the incoming connections that may arrive after the pod termination begins. It may take a while to update all kube proxies in your clusters and all components of the load balancers. Sometimes even 1 minute or more, depending on your cloud provider. If your application dies before all kube proxies and load balancers are updated, some requests may end up in void, causing errors on the client side. Also, your new replicas should not receive requests before they are ready for that. To ensure that, please set up readiness probe for your pods, and by the way, also liveness probes. It is a good practice even without horizontal pod autoscaler, but it's particularly useful when your pods are constantly starting and stopping. Also, please keep your metric server healthy. It is the source of CPU utilization metrics, and without it, HPA doesn't work. Last but not least, please enable cluster autoscaler. While adding new replicas, you may end up in the situation when there are no free resources in your cluster and someone needs to fix it. It will be either you who will receive the call or the automation. I will talk more about cluster autoscaler later in this presentation. Okay, what is the next big thing for horizontal pod autoscaler? The basic functionality has been there for quite a while. CPU-based scaling is considered GA, custom metric scaling is considered to be like late beta, but we are adding more knobs for advanced users. We have couple PRs in flight that will add more controls and speed for scale-up, scale-downs, and their sensitiveness. Moreover, we want to allow scaling down from 0 and to 0 for HPAs driven by custom metrics. The second robot from our happy autoscaling family is Vertical Pod Autoscaler. Vertical Pod Autoscaler monitors the real CPU and memory usage to estimate what should be the best pod size in terms of requested CPU and memory. Pod request is used by scheduler to decide where to put the pod, on which machine. Only machine that has enough free resources can host the pod. Pod request also defines how much request will be guaranteed for your application. If it's too small, then the application might be either throttled or may throw out of memory exception or both. If it's too big, then your resources are obviously wasted and your money is wasted. So it is quite important to set pod request right. So what does VPA do? Let's take a look at this example. Here we have a pod that uses 95% of the requested capacity. It's not the healthy situation. In this case, Vertical Pod Autoscaler will recommend to increase pod size so that the same load consumes only, let's say, 75% of capacity, not 95%. If the load on the pod is low for extended period of time, VPA will recommend to decrease pod size to free some space and allow better utilization of your machines. Vertical Pod Autoscaler can work in 3 modes. In first, it only provides recommendation, but doesn't change anything. The user is responsible for setting this pod request manually. In the second, slightly more automatic mode, it only sets pod requests for new pods. It doesn't touch the existing pods, even if they have suboptimal requests. The last mode, Auto, allows Vertical Pod Autoscaler to kill existing pods and recreate them with the updated requests. You can use Vertical Pod Autoscaler for both stateless and stateful workloads, especially if they cannot be handled with Horizontal Pod Autoscaler. And obviously, Vertical Pod Autoscaler is particularly useful when you have no idea what should be your pod size. And Auto mode is quite handy if your application can be restarted and you gained enough confidence with VPA recommendations when running it in recommendation-only mode. Vertical Pod Autoscaler is not a part of core Kubernetes. You either need to install it manually as an additional component or enable it on your Kubernetes managed solution like GKE with the appropriate cloud provider specific commands. Then you create a Vertical Pod Autoscaler custom resource definition object pointing to your application in a similar fashion as in HPA. However, this time you don't have a dedicated kubectl command. Now a list of best practices for VPA. As mentioned earlier, you should start your adventure with Vertical Pod Autoscaler in a recommendation-only mode. Give it a while, like a day or maybe more, to learn what is your workload, to see what are your daily patterns. Convince yourself that the recommendations are good, and then consider switching it to Auto. Vertical Pod Autoscaler is still in beta, so being a little bit cautious may be advised. While running in the Auto mode, please set pod disruption budgets. Actually, you should set them anyway for many other reasons. When configuring Vertical Pod Autoscaler, set minimum and maximum container sizes in VPA object, just to be on the safe side in outage-like situation. For example, when your traffic is not coming to the application for hours or maybe days, VPA might significantly reduce the pod size. And then, when you suddenly enable the traffic, you may have an unpleasant surprise. Vertical Pod Autoscaler doesn't update your deployment or stateful set specification. It only updates pods when they are created. So a good practice is to put reasonable pod requests, for example, taken from VPA recommendations in the deployment itself. Just in case you have some problems with VPA or someone turns off VPA accidentally. You don't want to lose this evaluated pod sizes. Vertical pod autoscaler doesn't like huge abrupt changes. For example, if you had 30 pods and you suddenly decide to turn your deployment from 30 to 5 pods in one step, it's not the best idea. You should do it gradually over a day. VPA stores history. So very significant changes like completely new image, complete redesign may require a new VPA object and maybe a new deployment with different label set. VPA takes metrics from metric server, so it is important to keep metric server healthy. And in the same way as horizontal pod autoscaler, you should enable cluster autoscaler in your cluster in case VPA enlarge your pod beyond your available capacity. Can you mix horizontal pod autoscaler and vertical pod autoscaler on the same workload? Well, the short answer is no. The more detailed answer starts with execute caution and it depends. Technically, you can always use vertical pod autoscaler in recommendation only mode and see what it says. It's safe, nothing bad should happen, and you can always discard the recommendations. However, in order to get stable results, you should either use custom metrics in horizontal pod autoscaler or absolute values for your HPA targets when scaling on CPU. And you should make sure that the application is getting enough traffic. Horizontal pod autoscaler should not be running at the absolute minimum number of replicas and way beyond the target utilization. Switching vertical pod autoscaler to auto when mixing with HPA is risky and shouldn't be done without a deeper understanding of HPA, VPA, and in your workload characteristic. Okay, what next with VPA? We have two major things on the roadmap. As I said previously, VPA is in beta and we hope to graduate it to GA soon. And we are working on the support for in-place pod request updates. Currently, in order to update pod requests, the pod has to be recreated and obviously your application has a small hiccup. This is not an optimal situation and we are working with community, particularly with the node and scheduling teams to fix it. Now the third and last robot, cluster autoscaler. Horizontal pod autoscaler and vertical pod autoscaler are targeted at scaling your workloads. Cluster autoscaler scales the underlying computing infrastructure. It provides nodes for your pods, that don't have a place to run. It also compacts underutilized nodes. It is based on scheduling simulation and declared pod request. It doesn't use metrics like actual CPU usage or QPSs. So let's take a look on how does it work in practice. Here we have 4 nodes with 4 pods. 3 pods are big, 1 pod is relatively small, and on that node we have a little bit of free capacity. If a new pod comes, then maybe it will fit into this 3rd node. The scheduler will place it there and it will start running there. However, if all nodes are kind of full and scheduler has no way of placing the pod, you need another node. And cluster autoscaler notices this situation. It talks to your cloud provider and spins up a new node. The new node arrives, scheduler notices it and places the pod on the new node. And everyone is happy. On some occasions, some nodes may not be utilized to their full potential. Let's take a look at this picture. Small yellow and green pods have nodes for themselves. If we move the green pod to the 3rd node, then the last node will be empty and can be safely deleted, like this, reducing your monthly cloud bill. And this is exactly what cluster autoscaler does. It adds and removes replicas as needed. When to use cluster autoscaler? The short answer is always, especially if you have more than 2 or 3 nodes in your cluster and your workloads change all the time. Cluster autoscaler works with multiple cloud providers. It has support for Alibaba, AWS, Azure, Baidu, Google Cloud Platform, and OpenStack running with Magnum. To enable cluster autoscaler, follow your cloud provider-specific guides. Some environments, like Google Kubernetes Engine, have built-in easy-to-use cluster autoscaler, but many require additional manual steps. Please check the appropriate documentation for details. Best practices. Use the hosted version of cluster autoscaler if your cloud provider supports it or has it in managed solution. Pick the version. If you're running it manually, pick the version of cluster autoscaler that matches your cluster version, or more specifically, scheduler version. There may be some subtle differences between scheduler versions, and they may result in inconsistent cluster autoscaler behavior. And define the pod disruption budgets for your application to make sure that the critical workloads are not moved too frequently or in large extent. As I mentioned it with vertical pod autoscaler, but it is also useful when running cluster autoscaler in your cluster. What's next with cluster autoscaler? Well, the project has been in GI for quite a long time and no bigger changes are expected there. Probably the only bigger thing that is coming is the support for cluster API to support more cloud providers and more environments like on-premise. As this talk is slowly getting to the end, I would like to give you a little bit more information about this Autoscaling Special Interest Group itself. We have meetings every Monday at 4 p.m. Barcelona time on Zoom. We have quite active Slack channel where you can ask questions, propose your new ideas. And most of our stuff, like cluster autoscaler and vertical pod autoscaler, sits in Kubernetes/autoscaler repository on GitHub. HPA itself is in the core Kubernetes/Kubernetes repo. And last but not least, I would like to invite you to other autoscaling talks. We have SIG Autoscaling Deep Dive, where we will get into details of cluster autoscaler and vertical pod autoscaler on Thursday at 3:55. And there are two talks focused on pod request in place upgrades. Both are tomorrow. The first one is at 11:05 and the second one immediately after at 11:55. And this is the end of my talk. Thank you for being and joining me today. And now we have a couple minutes for questions. We have someone with the mic, so please raise your hand and you will get a mic. Okay? Anyone? No questions at all? Okay. So, oh, here you are.
Okay, hello. The reason I'm here is that we're sort of shifting an old application to Kubernetes, and it fits fairly well. And one thing we want to do is to run optimization jobs.
Sorry, what type of?
Run optimization jobs that will take some time, and we want to autoscale the cluster nodes based on the number of, to use Kubernetes as a queue, more or less. Okay. So one thing I've been thinking about is it can't, the scheduler or the auto cluster scaler thing can't move things before the node is completely empty. Is there any possibility to do that? Yes, it can move pods before the node is completely empty. So the default setting is 50%. So if your if your node is utilized in less than 50% in terms of pod request, then cluster autoscaler starts to consider this node as not that much needed. And if it finds a place for all pods from this node to be moved elsewhere, and there are no system pods, node pods with restrictive pod disruption budget, and a couple of other conditions are met, then these pods may be moved elsewhere, the node will become empty, and then cluster autoscaler will remove it. Okay, So I think we can do what we want to then.
Yeah. Okay, there.
Do I need to do something special about my liveness or readiness probe when dealing with any of these autoscaling modes?
Sorry?
Do I need to do anything special in my code? Like
no,
typically
no.
We find that going like unready is a bad idea, so...
No. You shouldn't do like anything like super special. Your readiness probe should indicate whether your application is ready to take traffic. And that's true for the cases where you have autoscaling in the picture, as well as in the cases where you don't have autoscaling in the picture. Basically, when your application is ready, the networking part of Kubernetes adds the pods to the service, and the pods may receive traffic. If your application declares that it's not ready, or it's not ready yet, then the pods are not added to the service, and they will receive no traffic. So the readiness probe is not done for the autoscaling itself. It's done to make your networking aware of the state of your application. It wouldn't be that important if you had a very stable situation. So you start your pods at, let's say, January the 1st, and they run on the same machine for a year. It wouldn't make any difference, and if they were, ready for all the time. However, if you start pods, stop pods, start pods, stop, and stop pods, it's important to let your networking know what is the state of the application. If you don't specify anything, then as soon as the pod is started, almost as soon as pod is started, the pod is added to the service, but your application might still be initializing for the next 5 minutes. And if the request arrives, then it won't be handled properly. Okay, there.
You mentioned that I shouldn't stop accepting new requests when I receive a SIG term because of a movement event or a scale down event. So what do I actually do when I get SIG term? Because my understanding was that I would set readiness to false and continue processing the requests I have, and when I'm done with that, stop. But if I'm still supposed to get new requests, when do I stop doing that?
Okay, so let me answer that in more details. So what happens when your pod declares that it's unready or it's a start termination process? It is removed from the service endpoint list, and all of the kube proxies in your cluster will be notified about it. However, these kube proxies have a control loop, and control loop basically executes every 10 seconds. So if you are unlucky, it will take 10 seconds from the time that the pod is declared as unready to the time when it's removed from kube proxy on a particular node. If your cluster is big and there is a lot of going on there, it may take longer, like 20 seconds or 30 seconds. And during that time, all nodes or some nodes in your cluster will still think that the pod on the other side is there and will be able to accept new traffic. So it's a problem of letting all of the components in your cluster know what is going on, and it takes time. Also, on some cloud providers, updating load balancers take some time. So even if you declare that the pod is unready, this information is not applied to all components immediately. It takes time. So, and during this time, the requests will be flowing, so you either have to accept them, or your clients will get errors. So that's how it works.
So what do I do? Wait 1 minute and then stop
Wait one
shutting
minute,
down?
yeah. And then you will receive SIG kill signal. If at this moment your application will deplete its graceful termination time and will receive kill signal, or you can terminate after 1 minute, or you can also measure it on your cloud provider on your deployment, how fast it reacts, and wait for that amount of time. Everything depends on the specific environment. But it's important to pay attention to these little details to get the best experience with autoscaling. Okay, there.
So for this cluster autoscaler to work, do we need to use AKS or EKS kind of services, or?
Sorry, I didn't understand the question. Could you please repeat it?
Yeah. So my question is, for cluster autoscale to work, do we need to use Kubernetes services like AKS or EKS, or
no, you don't have it. However, services like hosted version of services may have a cluster autoscaler built in, and it will be easier for you to deploy it. On GK, it's just a single command to enable it. I believe on Azure, it is also like built in to EKS, so you can enable it quicker. But on other cloud providers, or if you are running Kubernetes in custom mode on cloud infrastructure, you just need to execute a little bit more manual steps. So start cluster autoscaler pod manually and configure it in a proper way.
Okay.
But you can use it on all of the cloud infrastructure I mentioned it. On some cloud providers it's a little bit easier, on some other it's a little bit more difficult, but in general you should not have like much troubles with it.
Okay. And does it work with VMware also? Or no?
Sorry, VMware?
Does it work with VMware?
Not from the core repository. I believe some work to support VMware was done, but I'm not exactly sure about the details.
Hi, thank you for the talk. Quick question about the testing and benchmarking. I'm quite new to the Kubernetes, so this might be a silly question. Once I configure my cluster with the autoscaling, do you recommend any tool to test or benchmark the configuration?
Yes, the general advice is to always test your deployments with something that closely resembles the traffic that you will get in your application. However, as I mentioned with VPA, right. Please be careful. So VPA stores history, and if you run a benchmark and then don't run the benchmark for, let's say, a week,
sure, yeah.
And then you enable full traffic at once, then VPA will be slow to responding to this traffic. So it will learn basically that there was nothing there for a week. Mm-hmm. It would recommend small pods, and it will take a while before it starts recommending like bigger pod sizes.
Right. Does it generate?
So,
I'm sorry, pardon me.
For that reason, you should, after running a benchmark, you should kind of lock vertical pod autoscaler with specifying its minimal container size, and ideally also put the recommended pod sizes to your deployment specification.
Right. Thank you. I will get more details on that later. Thank you.
Do you have any tips for scaling GPU accelerated nodes that take a long time to provision?
Windows nodes. Oh.
No, I said GPU accelerated nodes. GPU nodes.
GPU nodes. So cluster autoscaler supports GPUs. It waits until they are properly spinned, but well, cannot do nothing to make things faster. So I don't have like any like meaningful advices for scaling GPU nodes. It also depends what type of traffic you run it. Are you running batch jobs or some serving workloads?
Serving workloads.
Okay, so the general advice is to kind of try to fight with long pod or node startup time with over provisioning. So you need to over provision to cover all of the small spikes with enough capacity, and then set the, for example, HPA target to, let's say, low but still reasonable value. So as soon as it goes above this like standard spikes, it starts adding the capacity. But you should not depend on HPA with handling the regular spikes that you frequently get, like 5, 10, 20% spikes, because it would be like too slow to add the node or pods with the appropriate timing.
Thank you.
Hello, I want to set up a cloud bursting, and I looked into Federation. My problem is that V1 is discontinued, and V2 doesn't work with our vendor provided stuff because it uses different kind of resources, not the classic ones. Do you have any tips or pointers?
So I'm not up to date with the current status of Federation, so I don't know what to recommend to you.
Okay, thank you.
Okay, it looks like that we are run out of time, so thank you again for being here today and for all the questions.